In this video we're going to go through some more stuff about list comprehension. Okay, so let's remind ourselves about the range function. So let's do range 120. Okay, so that's let's do list range 120. So slight technical difference there. Okay, so this this gives us the numbers from 1 up to 19. Remember, the range, the first entry is always the first thing on the list, and then the last thing is kind of one past the end. So we don't actually hit 20, we only go to 19. Okay, so we could write it this way, and this is just I for I in the range from 1 to before 20. But we can look at the squares of these things. So let's call this squares. That's the squares of the numbers in the range 1 up to 20. So so yeah, we get the numbers here. One squared is 1, 2 squared is 4, 3 squared is 9, all the way up to 19 squared is 361. Okay. So now, what if we only want the odd squares? Okay, well, that's a couple of things we could do. Because I squared is odd if and only if I is odd, so we could do okay, so we're going to take squares for I in this range, but we're going to say here that we want I to be odd. So remember, I% 2 is I modulo 2, so I% 2 is going to be 0 if I is even and 1 if I is odd. So we put in this test, if I% 2 double equals 1, to only look at the odd ones. And remember, for testing equality, it always double equals. If you want to do an assignment, like here, where we set squares to be, we define it to be equal to the thing on the right-hand side, and we have a single equals. If we're testing equality, we have a double equals. Okay, so there's our odd squares, and then let's just print it afterwards. Okay, so then it's taken this list here, and it's thrown out the even entries and just taking the odd ones. Or a different way we could do it. Okay, so again, so here, kind of maybe the most common way to do these kind of loops is, I is in some range or other, but instead of I in a range, I can be in some list that we've made already. So here we've just got, we're letting j be one of these squares that we've got already, so it's for j in squares, and then we're just going to keep j itself, but only if j is odd, right? So for j to be odd is saying j% 2 is equal to 1. So notice actually, let's just do that again. Notice what happened here. I just typed an O, and the IDE guessed what I was trying to do. It gave me a bunch of things that I might be trying to write, and so I can just choose one of them by clicking on it. Yeah. Okay, so yeah, so so I got get the same answer this way, or yet another way I could do it is I could go back here. And instead of sort of saying that I is odd, then I could change my range, right? If I do range 122, so yeah, well, let's look here what this little information box that's just popped up. So it's the last, takes a little bit of work to understand what's going on here, but it says start, stop, step. And it's in square brackets, so it means that the step is an optional argument. We didn't have to leave it, put it in. But if we give it a step, then it does the range from the start to the stop, using the step. Step is usually 1, but if you specify something else, then it's something else. So here I've done 1 to 20 in steps of 2, so that's only going to give me the odd ones, and get the same answer yet again. And okay, so those and so let's do the cubes as well. So here I just did cubes and it prints it, but actually let's also try doing something a little fancier. I could just do, I just did print cubes, I get it as a flat list, which is maybe a bit more convenient, but also I can do something like this. So I want to do a formatted thing. So I'm going to do so I put this little F at the beginning, which means that this is a format string. So it's to be processed in the way I'm about to describe. So I'm just going to have this sort of header which says list of cubes, and then I'm going to have the list of cubes itself. So I put this in curly brackets. So because it's in curly brackets, it's going to fill in the value of that variable cubes that we just did. So now that's a bit more of an informative way to print the answer. So now let's try and find the squares which are also cubes. Okay, so let's here's one way to do it. We're going to say do a loop over the squares. Okay, so we have j for j n squares. That gives us all the squares back, but we've put in this extra condition, if j n cubes. So that's going to give us only the squares that are also cubes. Okay, and so there's only 2 of them, 1 and 64. Okay. That's 1 cubed and 8 cubed. So that's one way to do it. Actually, let's call that square cube 0. So here's another way we could do it. So basically, what we're trying to do is take the intersection of the squares and the cubes, but the squares and cubes, those are lists rather than sets, and intersection is defined for sets. So but we could just convert them to sets. Python's also willing to deal with sets. So okay, so we do set squares, so we're going to convert the list squares into a set, and we're going to convert the list cubes into a set, and then the ampersand sign is the sign for intersection of sets. We're going to get also a hint about that, but that's the correct notation for intersection of sets in Python. And so now we've got 164, but that's in curly brackets because sets are in curly brackets. If we want to convert it back to be a list like the other things, then we can just wrap this in list as well. Okay, and now so now it's come back out in the wrong order, but we can put sorted around the outside. That's sorted is a function for sorting lists, and so there we've got the same thing as our square cube 0. Okay, so far we've just been dealing with numbers. Let's do a couple more examples with strings.
So at the top of this notebook, I defined this string called long name. Let's have a look at that. So this is this very long name here. This is actually the name of a Spanish nobleman from the 19th to 20th centuries who was famous for having a spectacularly long name. So the name is kind of a bit too long. So well, actually, let's just check exactly how long it is. So the function len, it works a bunch of things. It works for lists and sets, but it also works for strings. So we can use this. So that name has 860 characters. So let's try and do the initials. Okay, so so what we're going to do. So if we do S for S in long name, so that's just going to give us this list of characters, right? It splits S in long name, so that iterates over all the individual characters in the string, and so now we've got a list of 860 things, 860 strings, each of length 1. Okay, but let's just keep the capitalized ones. Okay, so so I've just typed s.is, and you can see that the IE is suggesting some things to me. In particular, this is the one we want, is upper. So notice that's a method, not a property, so we need brackets. We need to check if each of these characters is an uppercase character. So that's good. Now we've got this list here. But we don't really want this as individual characters. We want to convert it back to a string again. So we have to do this string join thing. So we take the empty string and use it as a separator to join this list of strings here. Okay, so there we go. These are the initials of this bloke. Okay, so that's an example of how we can use this kind of list comprehension thing to do some non-trivial processing. But let's now try a slightly different approach. Okay, so let's split this into words. So you got there's this split method for a string which splits it, and we've put in the spaces. We're going to split up the spaces, so now we get all these kind of individual words here. Okay, and so we want to make the initials. We want to take the initial letter of each of these words. So we're going to do s of naught for s in this list. So now we've just taken the initial character from each of those individual names, and again we're going to combine it together with no separator, like so. And so it's a little bit different. Actually, let's just check the lengths. So that the first approach gave us 108 initials. As this one gives us 94. So what's the difference? Well, let's go back to here, and this is kind of a good exercise to make sure you know what's going on, to see if you can understand where this discrepancy is coming from. So let's go back to here. So 1 point, here we've got this name like Luis Clay de Francia. Okay, so
So in our first approach, we're just taking all the uppercase things. So we get the capital L, the capital R, and the capital F. We get three different characters from this name here. Whereas in the second one, we're doing this split thing. So we split here and here, and then we just take, this second approach will take this whole string, Luis Loreda Francia, as a single name and only give us the L, as opposed to the other approach, which gives us the capital L, the capital R, and the capital F. On the other hand, we go towards the end. I mean, we've got de Bourbon and e Bourbon here, and so this second approach, right? We catch the little d and the y there, as you see on the end. We've got these couple of lowercase letters, the little d and the y there, and in our first approach, we don't pick those up at all because we're testing for things that are uppercase. So there's kind of one reason why you get more in the first thing and another reason why you get less, but the first effect wins out, and so our first approach gives us slightly more initials than the second one. And that will do for list comprehension.